Welcome back to another deep learning video. Today we will be learning about something which is very important in terms of deep learning and where everything in deep learning begins. So let's just get started. I'll just give you what we're trying to learn today. Today we'll be taking a look at something called as Perceptron. Now the name itself sounds very confusing. The name itself sounds very scary. I know, but if you think about it, it's very simple. I'll try to give you two examples through real life examples, you'll understand what Perceptron does. So, if you guys have been following this series, this is video three of the deep learning series, and you guys can go check out the other videos on my channel. I've covered the basics of deep learning, and I've also covered why deep learning is preferred over machine learning, where machine learning fails. So if you guys haven't checked that out, the videos are on my channel and I'll leave the link to the playlist down below as well. So you guys can go check that out as well. So let's get started. Let's say you're a bouncer. Now, for the people who don't know what a bouncer is someone who stands in front of clubs or malls, and he checks everyone and makes sure that they are safe to enter the mall or pub. So let's say there is this entrance. You are a bouncer who is standing at the entrance of the mall. Now, you your job is very simple. You have to look at each person who walks up to the entrance, and you have to decide whether they can go in the mall or whether they get rejected. The first person, you'll check them and you'll do it. So, how do you make this decision, right? You probably will look at a few things, right? Now, first thing, you'll see if they are dressed properly, okay, whether they're dressed neatly to enter. If it's a very big club, you'll see whether they're dressed properly, or do they look old enough. So if it's like a very 18 plus club or 18 plus pub, you'll check if they look old enough, or you'll check their IDs. Or if they're trying to enter a VIP lounge or something, you'll check whether they actually are VIPs or not. So you take all these inputs and you weigh them in your head, and you'll make a yes or no decision to whether let that person in or not let that person in. So that is basically what Perceptron does. So it is the bouncer of the neural network world. So it will take inputs, which are the people, it will weigh them, and it will make binary decision whether to let them through or not. If you accidentally, let's say you are the bouncer and you accidentally let a 15-year-old kid into an 18 plus club. Now, that is a very traumatic experience for both you and the 15-year-old, because you are very scared of getting fired, and the 15-year-old is scared of something else. So, that is a very traumatic experience. What would you try to do next time? You would try to avoid it, right? In the same way, uh, through mistakes, our perceptron also is able to avoid these mistakes. So, if it lets someone who shouldn't be there, then it adjusts its decision making process just like you would. Now, that is the main reason deep learning is very popular, because deep learning, when it was designed to uh, mimic the human brain. This is my interpretation of a human brain. It is designed to mimic the human brain based on the decisions or based on the mistakes the human has done. He will try to rectify his approach. In the same way, machine learning or neural network, also based on the mistakes it has done to predict the outcome, it will try to rectify itself. Now, this is something which is very dynamic. It hasn't been explored much in the machine learning side, and that is why deep learning is one of the most important topics that is going on right. So you basically understood what a perceptron does. I will give you another example as well. Imagine that you are a botanist. Okay, so what does the botanist do? He'll think about different plants. Now you have collected data on two types of flowers. One type of flower has red, is species red. The other type of flower is species blue. Two flowers. You have discovered two flowers, and you have collected data on two flowers. And let's say they are plotted on the data axis like this. So the red flowers looks something like this, okay, on the data, and the blue flowers look something like this. Now, if you were to give a new flower, let's say which is over here, your brain would automatically say that this belongs to the red species. How? In your brain, you automatically drew a line which separates these both places, and since this point lies on the other side of this plane or this line, you were easily able to say that it belongs to the red species. If the same data is three-dimensional, probably your brain would plot plane to distinguish these stuff. So this exactly is what the perceptron does. Okay, so what do you mean by perceptron? What do you mean by a perceptron? Perceptron, you can think of it as a function. What is a function in a programming, in programming approaches, or what is a function in mathematics? It takes some input and provides an output. Okay, now the functionality of this function is something the someone designs. Now, perceptron, you can say that it is kind of a mathematical function. This function will take several inputs. In this, I'm denoting this with a box. It takes several inputs and provides one output. Now, in the bouncer example, these inputs might be age, these input might be dress code, or these inputs might be what else, or it can be VIP, is VIP or not. And this function will take those inputs and it will decide an output to whether let the person in or not. Now, the thing which I've written right here, right now, this is called as a perceptron. This is a perceptron model which I've drawn right now. The image here is a perceptron model. Now, if you were a bouncer, so I'll call this function a bouncer function. Now, if you think as a bouncer, you might have different things which you can think about letting a person in or not. So let's think about it. Now, if you have someone who is below 18 years old, you won't let them in. If you have someone who has inappropriate dress code, you'll not let them in. Or if someone is not VIP, you'll not let them in. So out of these three, which one do you think is the most important thing to, let's say you're attending a VIP function, okay? You're having a VIP lounge and you are assigned as a bouncer to that VIP lounge. Now, your job is to take a look at people and let them in. How do you let them in? How do you think you can let them in? If you go and check each person, you would give more importance to the fact that that person is a VIP or not. Yes, because if that person is not a VIP, there is no point in checking the age or the dress code of that person. You can straight up reject that. VIP here, the person being VIP here has more significance than the person's age or the dress code. So you can see that this VIP part of the input bears more weight towards the output or towards how the output is decided. So if the person is not VIP, we can straight up say that he is not allowed. But if the person is VIP, we can say that he is allowed. If the person is VIP, you'll check the other stuff of the VIP as well. Now, the next important thing, which I think you should check, is the age of the person, right? If the person is indeed a VIP and it's an 18 plus club, so maybe it's better not letting a 15-year-old VIP person into the club, right? Because it's an 18 plus club. So maybe the next important thing is age, which you want to identify from this. And finally, if all those characters are decided properly, then you'll see the dress code of the person and you'll make a decision whether to let them in or not. Now, the you can see we have different priorities for different weightages for each input we have in the bouncer function, right? So VIP bears more weightage because if it is not VIP, then there is no person in there. You don't let the person in there. But and the next most important thing is age, and the final most important thing is the dress code. So you can see VIP has more importance, more weightage to your output. Now, these are called weights in perceptron. What are these weights? These weights are basically numbers which show how important is each input. Okay, so maybe the person being VIP is the most input. Maybe the person having age is more important than the person's dress code. So, how does your model know which feature is important and which is not? You can use weights in order to know whether a particular feature is important or not. Now, you've seen what inputs are, you've seen what weights are. Now, if I try to map this function mathematically, this bouncer function mathematically, I could write it in this way. Okay, so what does the function take as inputs? The function takes input as VIP and age and dress code, and the output will be either yes or no. Now let me try to like write a mathematical function. Okay, so if let's say I'll denote VIP with x1, age with x2, DC dress code with x3. Okay, and I think the weightage of VIP on the output I'll call it w1. The weightage of age on output I'll call it w2. The weightage of dress code on the output I'll call it w3. Now I can kind of make a mathematical function out of this, right? So I'll call it w1 x1 plus w2 x2 plus w3 x3. Now, whoa, this is a big step. What are we doing here? I'll say my output is this one. How did we get here? See, x1 is a feature of VIP, x2 is a feature of age, and x3 is a feature of dress code. Now, weight W1, W2, and W3 are weights of the features, respectively. Now, let's move aside from this for now on, and I'll tell you why we are exactly multiplying this. So, I'll give an example. Let's say you have written an exam out of 100, okay, and you scored 80 marks out of that 100 in your first test. Let's say you wrote a series of two tests. In the first test, you have written score of 80. You got a score of 80. In the second test, you got a score of 92 out of 100. You are super stoked about this because you think uh, both of them, I wrote them well, and in average I think I'll score around 80 plus 92 by 100, which is 86 out of 100, and you feel like you have done a very good job thinking. But your teacher comes in and tells you that the first test bears more weightage than the second test. So you might be asking your teacher what is the distribution of each marks. So she would say, I would consider your first test for 70% of the marks and the second test for 30% of your marks, final marks. So in that case, how would you calculate it? So from this, you are only supposed to take 70% of the marks. From this, you are supposed to take 30% of the marks. So in that case, you would just do 70% of 80 plus 30% of 92, right? Now, how would you calculate this? This is 70 by 100 into 80 plus 30 by 100 into 92. Okay. The whole one is 70% of this and 30% of this. Now, this evaluates to 56 and this evaluates to 27.6. Now, if you add both of them, you will have 83.6. This is slightly lesser than 86. Why? Because your score decreased because there is a high weightage to the one which you scored less in, 80 by 100. There's less weightage to something which you scored more in, which is 92 by 100. Now, how did you find the weightage of it? You just multiplied. You just multiplied your score with the weightage. In the same way, in Perceptron as well, you are multiplying each input you are given with a weight. Okay, and this one overall will give us the weightage of how much that input is required to get the output. Now, this is what the neural network can use to correct itself. It can tune these W values by itself based on the output which it has learned and be able to specifically write certain output answers. So again, all of this is going too far, but I really want you guys to understand the perception and the intuition between why we multiply stuff. So that's all. That's basically what perceptron is. You take each input, and through each input, you will multiply a certain weight to that input, and it will basically create a classification for you. Now, let's take a look at this. Now, let's move on. I hope you guys understand what Perceptron does now. Now that I've given this example, each age of the VIP or the weightage of VIP is dependent on the values of this W1, W2, and W3. And the neural network will be able to tune these values in order to improve itself so that it can provide better prediction values for you. Now, mathematically, I can denote it like this. So I'll just try to draw a simpler diagram for you so that you guys can understand this easily. So I'll call this as a function f, and this function, which is a perceptron function, I'll give it several inputs. It doesn't need to be three; it can have many several inputs. X1, xx or xn to xf. Okay, so I'm just denoting several inputs, and it will have an out. Now the each input will have its corresponding weight. So x1 will have a weight w1, xx will have a weight wx, and xf will have a weight wf. Okay, now mathematically I can denote them in this way: w1 x1 plus w2 x2 plus so on up till wx xx plus so on until wf xf, and this will be your output here. This would be your final output. Now this is how perceptron will look. But if you've noticed something cool, I'll just draw a perceptron which has a single input and a single output. Okay, so my perceptron has a single input x with the weight w and my output o, and the function is this. Now how would I denote this? This would just be wx. Okay, my output is equals to wx. This is cool. Now perceptron with two inputs, I'll try. So it is xw, uh, y w y, wx wy, and I'll just map it to the output. Now if I try to map this, I'll get wxx plus wyy is equals to O. Now, this, if you are able to see, this is not zero, this is O output. O stands for output. So, now if you take a look at this equation, it looks like an equation of a straight line, right? You might have seen in geometry that any equation with a degree of 1 is considered as a straight line. Now, now this straight line we can identify in the example we have seen above, the example of a botanist example. Your mind, I said, has created this imaginary line, right? And perceptron as well will do the same thing. But this line, whatever we have right here, this is the line wx plus wy as the output. Now, this is the line which you will be able to use to classify whether some flower is red or some flower is blue. Now, that is something which people don't know about perceptron. Perceptron is used for drawing a straight line so that it can separate several groups as accurately as possible. Now, how? It first tries to draw a random line. The perceptron will try to draw some random line, but it will adjust its weights, whatever it has, in order to steer this line back to the proper fitting line. Now, when a perceptron learns, it is just trying to figure out how to draw this line so that it can separate these two groups as accurately as possible. So that is basically what perceptron means. Perceptron does. So this is the output of the perceptron. Now, if you want to modify this kind of line by yourself, there is something called as a bias. Now, bias is something you can add to each value of a perceptron. It's like you can think of it like an input to each perceptron, so that this bias has no weight. Okay, the bias weight is one. Uh, the weight is not zero, because if you multiply anything with zero, that means that input has no weightage. So we are not saying bias has no weightage. Bias has some weightage. We'll multiply it with 1 so that the value is carry forward as it is. So in this case, it will be wxx plus wyy plus 1 is the weight of the bias into p is the output. Now, this is another function, and this bias value is another learnable thing which the model can adjust in order to learn. Why do we add this? We just add this because we want the model to shift not only in the input directions but in the constant direction as well. So you'll learn more as you try to build these models, but I am just trying to make this class as informative as possible while having to know as less things as possible. So I think that's enough drawing on this stupid whiteboard we have. We'll just take a look at some stuff in action, and I'm going to show some interactive demos where you can watch a perceptron learn in real time. And I think that would maybe spice up the knowledge you have even more. Okay. So huge shout out to this website right here. I'll leave a link to this in the description so that you can go check it out. And I think we'll just take the same example as the botanist example we've took. We have two classes, blue and red, and we'll try to figure out proper function to map blue ones and red ones separately. We want to classify blue and red separately. So I'll just plot some blue lines on the canvas. You can just click them like this, and you can see I have a lot of blue lines. So let me just show and plot some lines, plot some points right here. That's it, that's blue. And I'll plot some red lines here as well. So there we go. That's a lot of red lines. You can see whatever I'm plotting, you're able to, on the right, you're able to see where I'm plotting the values. Now, if I just click on train perceptron, you can see it has created this very nice, cool boundary in order to, classify these both values. That was my bad. So it has created this very nice boundary. And if I go into test mode here and I add any new points, you can see since it's on this part of the line, it has predicted that it is blue. And since I'm on the other part of the line, it has predicted that it's red. What if I put it exactly on the line? Some parts it is showing it as blue, some part it is showing it as uh, red, but that completely depends on how much you do it. Now, this kind of data is really good because you are easily able to separate two values based on this. You can see it here as well, based on the function we wrote. Now, what is the sign? I'll tell you what it is later on. But you can see have triple one training points, and the accuracy is 99.1. And as you try to add more and more points, let's say you've added more points of red over here. Okay, you added more points of red over here. And now if I click on train, you can see that the decision boundary has slightly shifted. If I add more blue over here and train it again, you can see the decision boundary has slightly shifted. Uh, this it is doing by just modifying its weights. Okay, so as soon as new data comes in and you're training it again, it is shifting its original knowledge to adjust to that new data. How? By just modifying the values of these weights. Now, we didn't see the whole thing yet. We didn't see how you can adjust these yet, but I want you to have a clearer understanding. Now, this is good and all, but I think there is one problem, one clear problem, which a lot of people might have noticed by now. So let's say I have data like this. I have blue data like this, and I have a red data in the middle like this. Now look at what happens if I try to train this person. You're getting classified. You're classifying it as you're classifying it very wrong. The decision boundary is somewhere over here. Every point I put here, it is classifying it as red, but every point I put here, it is classifying it as blue. Definitely, this is wrong, right? this is not how you should classify the model. But why is it doing this? So this is the limitation of a singular perceptron. Now the perceptron which we were talking right now, this is the only limitation of it, which is that it can only learn linear decision boundaries. So if you have only one perceptron, it can draw a singular line. If you have multiple perceptrons, then that means it can do something which is non-linear as well. So that is the main reason we can create logical decision boundaries by just not using a singular perceptron. We can use multiple perceptrons together as a layer or as a stack in order to predict different stuff. Now this is where I'll be stopping this particular video. We have learned a lot. We have seen what perceptron is. We have seen how it works. We have seen what it does. And I think with this video, you have a basic understanding of perceptron is. And if you don't worry. We'll keep going until you guys do understand what perceptron is. We have a lot more exercises planned. We have a lot more stuff planned. And this course will teach you everything. So if you guys did like this video, make sure you go smash that like button. And thanks for watching. I'll see you all in another video.